All right, y'all. So now we are on to level 3 of AP questions. The first one was kind of a plug and chug, just put the information in the equation. The second one was kind of starting to get us to think, but we didn't actually really have to do much math at all. This one's getting a little bit more difficult because we're going to have to interpret a graph to be able to answer the questions. All right. Now we're going to be continuing to use the same equations before. I haven't put them here, but hopefully you've got them written in your notes. All right, so here we go. Level 3, a 0.5 kilogram cart moves on a straight horizontal track. So side to side, again, one-dimensional, just like all the other questions we've done. Graph of velocity versus time for the cart is given below. Indicate, and here's your graph. Notice we got velocity. This is our horizontal velocity here, and we've got our time here. Now, just kind of to help you connect with what's happening here, right at the beginning, this is 0.8 meters per second. Now, it's not moving down. That means that it's moving at 0.8 meters per second in the positive direction. So it's moving at 0.8 meters per second to the right. Okay? Now, as time progresses, you'll notice that as time goes a little bit further, that the speed is now 0.4 meters per second. What does that mean? Well, it means that it's now half as fast as it was, so 0.4 meters per second, right? So we see that as the graph goes down, that doesn't mean our object is going down. It's telling us about the speed, the velocity of the object. Now, it is velocity here because it's positive, and then it drops down to negative. And remember, a negative velocity just means that it's now going back in the other direction. It's going back to the left. And so it's going to the left through all of this. We'll spend more time interpreting graphs and things like that, but I think this is a good introductory question to that and be able to kind of think through what's happening. All right, so we've got in letter A, indicate every time for which the car is at rest. So when it's at rest, that means that my velocity should be 0. And so I'm just going to go along the place where the velocity is 0 here and find the times when it's 0. So right here, so at 4 seconds, and right here at 15, 16, 17, 18 seconds. Everywhere else, the object is moving, right? It's either moving to the right or it's moving to the left. All right, that's it. So now we're ready to move on to part B. Part B says indicate every time interval for which the speed of the cart is increasing. All right. So let's think about when would the speed be increasing? Well, we talked about right here that it was going from 0.8 down to 0.4, so that's definitely slowing down. All right, slows down, it gets to 0, and then what happens? Now it goes to 0.2, and then 0.4, and then 0.6. Notice that its speed is getting higher and higher. Now, it's getting negative, but remember, negative just means to the left direction. So it starts at rest, and now it's moving. So therefore, it's getting faster, right? So everywhere from time 4, and we can write it like this, from 4 all the way down to here, which is 9, it's speeding up. And then it gets here where it's going -1 meters per second, and now it's going -8. And you may say, yeah, but the graph is going up. No, that's not important. That means that the velocity is increasing. That doesn't mean that the speed is increasing. The speed went from 1 down to 0.8, right? Because the negative, remember, is just the direction. So it's actually slowing down here. All right, slowing down, getting closer. Anytime you're getting closer to 0, you're slowing down. So slowing down here, we continue at this speed for a little while, right? We're continuing at that -0.4, and then we start going towards the 0 again. It looks like we stopped here, but that's not stopped. That's 0.4 meters per second to the left. So we're still going towards the left, going to the left, and then we start to slow down. And then at this point right here, we hit 0 again, and then we start going away from 0. And remember, if we're going away from 0, our speed should be increasing. So from time 18, we identified that before, 18 up to time 20, so 18 seconds up to 20 seconds, all of that will be increasing speed. And then again, it flattens out. We continue at this 0.8 meters per second for a significant amount of time. All right, so that was B. And moving on to C, determine the horizontal position of X of the cart at T equals 9 seconds if the cart is located at X equals 2 at time 0. Woo! All right, so that's a lot of information, but recognize that it's giving me, it's asking for position, okay? It's given me at time 9, 0, and it's saying at X equals 2, then the time is, it starts at X equals 2 at time 0. All right, so I need to go from 0 down to 9 seconds. So that's this point right here. Now, one of the things that we notice is that this is a constant change in velocity, right? The velocity starts here, the velocity changes, but every single amount of time that passes, the velocity changes by exactly the same amount, okay? That's a constant slope, but what do we call a change in velocity? Well, remember that a change in velocity over time is acceleration. So if that change is constant, then that means my acceleration is constant. If the acceleration is constant, that means that I can use my kinematics equations. So let's see what information we have. All right, we know that the initial position is at X equals 2. So I got initial position, initial velocity, final velocity, acceleration, and time. So at the initial position at time 0, I am at 2.0 meters, okay? 2 significant figures, okay? I'm looking for the horizontal position, so that's this guy right here. I've got velocity, initial velocity. The initial velocity was that 0.8, it's positive. Final velocity is right here. That's negative 1.0 meters per second. I don't have the acceleration, so I'm going to leave that for now. And then time, it goes from 8 down to this, and it does say at T equals 9 seconds. So 9 seconds have passed. And notice that's also in 2 significant figures. Now, this one is only 1 significant figure. All right, that's 0.8. Now, if you think that you can estimate that well enough and it looks like it's right at 0.8, we might just say, this is 0.80. So now it's 2 significant figures. If you think it's close enough to that 0.8 that you can reasonably say 0.80, then do that. Then everything has 2 significant figures. All right, so now with this, we're ready to attempt to answer this question. Now, in looking at my equations, right, I've got the x equals x naught plus v naught t plus 1/2 a t squared. I am hoping that I don't have to use acceleration here, but that one's got acceleration, right? I would have 2 variables. I'd have acceleration and I'd have position. I'd have 2 different variables. So the next one is v equals v naught plus at. That one, I could solve for a, but it doesn't actually find x, right, which is what I'm looking for. My last option is to do the v squared equals v naught squared plus 2ax minus x naught, and unfortunately that one has a and x in it as well, so the 2 variables. So unfortunately in this one, we're not going to be able to answer this in one step. So what I recommend is start with the easy one, right? Let's go ahead and start with this guy right here because that will allow me to solve for A. Now, in the previous question, we said, well, let's not worry about the thing that we don't have and we don't need. But in this situation, it sure would be nice to have acceleration because all 3 of our equations actually require acceleration, right? There's 2 variables that you have to have in order to use kinematics. You have to have acceleration and you have to have initial velocity. Notice that they all have those 2. Now, if you have one of those, then very often you can solve for the other one, right? If you have everything else. So let's go ahead. We're going to use this equation right here. We'll go v final velocity, which is negative 1.0, equals the initial velocity, which was 0.8, plus a t, and t was 9. And so we should just be able to solve for that. We'll take our -1 there, and then we will subtract the 0.8, and which will give you the -1.8, and then we'll divide by the 9, which will give us, I know you guys like your decimals, so we'll go A equals -0.2 meters per second squared. And now don't worry about the negative, right? The negative just means that I started with a positive velocity and my velocity is getting lower and lower and lower, that it goes into the negatives and then it continues going in that negative area. So now I have the acceleration, but remember that wasn't the question. The question was to find x. But I can actually put this piece of information into my my grid here now. And so now I have everything except for x. And so I can use either of these two equations now. Either one is fine. But once again, I encourage you to use the one that's easiest, right? If you use this one, you're going to have these squareds. You're going to have to end up solving for x. This one, x is already where it needs to be. So this one actually, in my mind, looks like a little bit easier equation. So let's go ahead and use that one. So we'll take our x, which is what we're looking for, is equal to x naught, which was 2, plus v naught, which is that 0.8, times time, which was 9, plus 1/2, times a, times that time squared again. Now, notice again that when I do my equations, I'm leaving out the units. I'm leaving out the units because I made sure that everything was in SI units, meters, seconds, meters per second, meters per, it's all in SI, which means my result will be SI units. The second thing is, notice that when I had the 2.0, I didn't write it, I just wrote the 2. I've already paid attention to my significant figures here. I already know I need 2, so therefore when I'm doing the math, it's not necessary to write every single one of those digits down. I don't need the 0, okay? So at this point, we should just be able to put all that into our calculator. So we'll go 2 plus 0.8 times 9 plus 1/2, which is 0.5, times -0.2 times 9 squared, and we push enter, and we get that x is equal to 1.1 SI units, so that should be meters. All right, so there you go. We were able to answer a level 3 question. What made it level 3 was this idea that I had to be able to glean the information from graph. It wasn't all given to me. And the fact that in this case I didn't have acceleration, so I had to use this to get the acceleration, which then allowed me to solve. Now, there's other ways to do it. You could have used these two equations. They both have a and x, and then you could use simultaneous equations, right? You can solve by substitution or elimination or by graphing, right? You can use your calculator by all means. So there are different ways to do this algebraically, but in my mind, it's easiest to solve for one and then solve for the other whenever you have that opportunity. All right, so there you go. That is a level 3 AP 1 kinematics question.